Hansla, kindly mark your attendance in a chat box, okay? We will start lesson after 5 minutes when all the students join the class. Hansla, we will wait 5 minutes, then we will start the lesson, okay? Because nobody can still join the class. Hassan, beta, kindly mark your attendance in a chat box, okay? And Hassan, also turn on your camera. Okay, Hansla, can you tell me what is the what is the relation we have learned the class regarding resistance? What is the formula for resistance? Can you tell me?
R is equals to V divided by I.
Okay, or we can say that V is equals to I R.
R.
Okay, this is an example that is mentioned in your book. This is example 14.2. A battery of 12 volt passes a current of 0.5 ampere through a resistor. Find the value of resistance. So in this problem, basically we have to find out the value of resistance. This 12 is the potential difference. So we write here, right over here, V is equals to 12 volt. Current is 0.5 ampere. So I is equals to 0.5 ampere. A is the symbol for ampere. Then we have to find out the resistance. We know the Ohm's law is given by V is equals to IR. As we have to find out the resistance, so we have to take I on the other side, so it will be divided. So R is equals to V by I. Put the value in this formula, you will get V is 12 volt, I is 0.5 ampere, and dividing 12 by 0.5, we will get 24 ohm, right? So this is the answer for resistance. And we know that the unit for resistor is ohm. So we put the symbol of ohm over here. You know, you don't need to do this in your notebook. Just understand over here. Okay, the next slide is a battery torch bulb uses two cells, each of 1.5 volt to glow, right? So we are using the two cells over here, and they have the potential difference, or we can see the voltage of 1.5 volt to glow. What current will flow through the circuit? So it's mean we have to find out the value of current. So we write here that we current that we have to find out. So the circuit of torch, when its resistance is 20 ohm, resistance is given to us, that is 20 ohm. So as we are using the two cells, so what we do, we will multiply 2 with 1.5 volt to get the total voltage or potential difference that is present in the this torch bulb, right? So after multiplying 2 with 1.5, we will get 3 volts. So again, we will use the same law, that is Ohm's law. We know that Ohm's law is V is equals to IR. As we have to find out the value of current, so I is equals to P by R, right? So put the value in this formula, we will get I is equals to 3 divided by 20. Okay. So after dividing them 3 by 20, we will get 0.15 amperes. This is the value of current that we have to require to glow this torch bulb. Now we are going to start the next topic, that is combination of resistor. As we have learned the combination of capacitors in previous unit, similarly we will learn in this unit combination of resistors. Again, we have the two combinations of resistors. One is series combinations of resistor and other is parallel combination of resistor, right? So in series combination of resistor, basically we combine the resistor in series because to get the low value of resistance. If we want for a high value of resistance, if we want a very large value of resistance, so what we do, we will connect it them in series, and for small value we have to connect them in parallel. So taking start with this series combination of resistor. So how the resistors are connected in series? Series mean they are connected in a line. So if you see the figure, they are connected end to end. From this is the left side of the resistor, this is the right side of resistor. From this right side, the other and other side is left. So they are connected from end to end. One from one end of the resistor is on the left side, so other will be on the right side. So as they are connected in the line, so we call them they are connected in series. Then we have to connect them with a battery. So battery will give them potential difference, which will use to flow the charge in the current in the circuit. So this is the circuit diagram of the this combination of resistors that are connected in series. We have taken three resistors R1, R2, R3. R1, R2, R3. All of them have the different value of resistor, and this is the potential difference. So this voltage is same, right? So when we on this battery, the potential difference will be, with the help of potential difference, the current will be flowing in this circuit, and this current will be same throughout all the circuit, because when we connect this resistor in the series, we will get the same amount of current. So across R1, the current, if the current will be I1, and across R2, the current will be I2, and across R3, the current will be I3. We name them as the current I1, I2, I3, but all of them have the same value, means they are equal to I. Means the total amount of current that is flowing in the circuit will pass through R1, R2, R3. As this current has the same value, so we can write it as I1 is equals to I2 is equals to I3 equals to I3, right? So in case of series, the current we are using is the same. Moving towards the next slide. See, in case of series circuit, when the resistors are connected in series, the voltage will be divided across each resistor. So what is the reason behind that? The voltage will be divided because the resistor that are connected in series have the different value. So for R1, we can say that the voltage will be V1. For resistor R2, the voltage will be V2. And for voltage R3, the voltage will be V3. So in case of resistor, when they are connected in series, the value of the potential difference will be divided among the circuit, right? So we can say that when we take the sum of all three potential voltage across each circuit, then they will equal to the total amount of the voltage, right? So with the help of, as we know that the voltage is different, so we can take the equation as V is equals to V1 plus V2 plus V3. Keep in mind that the current flowing in the series circuit in case of resistor, it should be same, but the potential difference will be divided across each resistor because the value of the resistor will be different. R1 has different value than R2, and similarly R3 has a different value than R1 and R2. It's mean we have connected the three resistors in series. They have the different value. Might be this R1 has the 2 ohm, this R2 is 3 ohm, and this R3 will be, so let's suppose 5 ohm. So they have the different value. So when we take the voltage across all the three resistors, their value would also be different. Okay, moving toward the next page. So as we know that according to the Ohm's law, we know the relation V is equals to IR, right? So we know that the voltage will be different. So we know that V equivalent will be equal to V1 plus V2 plus V3. So by using this Ohm's law, we will put the value of these voltage in this equation. We will get V is equals to IR. So instead of V, we can put IR equivalent because this R equivalent is the total resistance in case of series resistors, right? This V1 is equals to I R1 because on the resistor R1 we get the value of potential difference is V1 plus I R2. This R2 is represent that the voltage will be V2 across this resistors, then IR3. So it's mean this R3 has a voltage V3, right? So this equation will be IR equivalent is equals to IR1 plus IR2 plus IR3. So left side equation as it is IR equivalent is equals to, now we notice that on right hand side this I and I can be taken as common. So we can take this I as a common because I along throughout all the circuit is same. So we can take this current as common. Then we will left with R1 plus R2 plus R3. So as we have current on both sides, so this current will be cancelled out with the current on the other side. After cancelling them, we will get the relation R equivalent is equals to R1 plus R2 plus R3. So this is the value of resistor in case of series circuit. When we connect the resistors in series, we will get the relation R equivalent is equals to R1 plus R2 plus R3. In case of series resistance, all the resistance will be added and we get the very large value of resistance. So where we need the very large value of resistance, usually we connect the resistor in series combination, right? So here we just taken the 3 resistor. So we write this equation R1 plus R2 plus R3. But let's suppose if we have a we have to connect the 4 resistance, we have to connect the 5 resistance, 6 resistance, or so many resistance. So we can add them accordingly as it is mentioned in equation 14.7. So for if we have n number of resistors that are connected in series, the equation will be R equivalent is equals to R1 plus R2 plus R4 plus so on plus Rn. So we put the value of n depending that how many resistance we are connected in the series. If n is 5, so it's mean it will be R4 plus R5. If n is 6, so we can take them R6. If n is 7, so we can take the resistors up to R7. So it depends upon the value of n, that how many resistors we have to connect it in the series. Keep in mind, whenever we are connected the resistor in series, they should be connected along a same line. So when the resistance they are connected along the same line, they are known as that they have the series combination, right? In series combination, the resistance they have connected end to end resistance. The answer of the total resistance will be we get the greater value of the resistance. And whenever in a daily life we need the greater resistance, we have to connect all the resistors in series, right? Okay. So we can now we will discuss the same problem regarding we have discussed the resistors in series. If you see the example that is mentioned in your book, 3 resistors R1 10 ohm, R2 20 ohm, R3 is 30 ohm are connected in series across 20 volt battery. Find the equivalent resistance and voltage drop across each resistance. Okay, so the data, first of all, we have to write the data. That is R1 is 10 ohm, R2 is 20 ohm, and R3 is 30 ohm, and potential difference is 20 ohm. Okay, Hansla, can you tell me which quantities we have to find out in this example? All 3 resistance are given to us. Potential difference is also given to us, and what quantities we have to find in this given problem? Yes, Hansla.
Voltage and resistance.
Yes, we have to find out the equivalent resistance, that is the total resistance of all the resistance, right? Okay, Ayan bin Faisal, can you tell me what other quantity we have to find out in this example?
Voltage drop.
Voltage across
Each resistor.
Yes, very good. Voltage across each resistor. So it's mean we have to find, when we have to find out the voltage across each resistor, then we have to find out the V1 individually, V2 and V3. So now we have write all the data that is given to us, and that we have to find out. Now we are moving toward the solution. So we know that in case of series combination, the equivalent resistance is given by the equation R equivalent is equals to R1 plus R2 plus R3, right? So putting the value in this equation, R1 is 10 ohm, R2 is 20 ohm, R3 is 30 ohm. We just simply add these resistors, that then we will get the answer 60 ohm, which is equals to the equivalent resistor, or we can say the total resistor, right? Then we have to find out the voltage across each resistor. So to find out the voltage, first of all, we know the value of current. But if you see the statement of the example, the value of current is not mentioned, right? So the value of current is not mentioned. It's mean, first of all, we have to find out the current. And we know that whenever we are taking a combination resistor in series, the value of the current will be same, right? So the formula for current is, again, we will use same Ohm's law. V is equals to IR. So it's mean V by R is equals to I. So this I is the total current that is flowing across the circuit. So the value of V is given, that is 20. So we will put 20 over here, and we find the total resistance now, that is 60. So we have to divide 20 by 60, and we will get the current that is 0.33 ampere, right? Okay, now as we have calculated the value of current. So now we have to find out the voltage across each battery. Again, we will use the same Ohm's law. V is equals to IR. As we have to find out the voltage across V1, so we will use V1 is equals to IR1, right? V1 is equals to 0.33 multiplied by 10, which give us 3.33 volt. So this is the voltage across V1. Again, we will use the same formula. V2 is equals to IR2. Putting the value I is 0.33 ampere, R2 is 20, so we will get 6.67 volt, right? Third, we have to find out the voltage across third resistor, so we'll put the value I is 0.33 ampere, R is R is 30, and we will get 9.99 volts. So in this way, we have find out voltage across each resistor. That is that statement have asked us to find out, right? So this is a problem that we have done with it. Now, the next topic is resistors that are connected in series. Sorry, parallel. So in case of parallel combination, again, when we learn the topic parallel combination of capacitors, similarly, we have to connect the resistance like this. See, they are connected parallel to each other. See, this is the resistance R1. This is a resistor R2. This is a resistor R3. So it's mean these resistors, they are parallel to each other. Means, see, this resistance R1, R2, R3, they are not intersecting each other with at any point. So we call them, they are connected in parallel combination, right? So again, we have to take the three resistance similarly in case of parallel combination R1, R2, R3, and the potential difference, that is the battery, and we connect them separately. So this, so one end of each resistor of one end is connected with the positive terminal of the battery, and other is with negative. This is connected with the positive. This is connected with the negative. This is connected with the positive terminal of the battery. And this is with the negative. So it's mean when they are connected like this, the voltage across each resistor will be same, because each resistor is getting an individual voltage, that is a total amount of voltage. So we can say that the potential difference in case of parallel combination, all the resistors, they are getting the same amount of voltage. So we can write the equation V is equals to V1, which is equals to V2, which is equals to V3, right? But in case of parallel combination, the current will be divided, because when the current flowing in the circuit, it will go first toward this resistance and it will divide it over here, and it is represented by I3. Then it will go to the next resistor and it will be mentioned as I2. Then the other resistor, and it will be I1. So in case of parallel combination, the value of value of current will be changed, right? But the amount of voltage will be remain same throughout the circuit. So we can say that I is equals to I1 plus I2 plus I3. Keep in mind, when we are solving these combination resistors, or when we were solving the combination of capacitor, the equation that is having the addition sign in this equation, basically we put the values of the rest of quantities to solve this equation and get the desired value, right? Okay. So as we know that V is equals to IR. V is equals to IR. So as we have previously, we have learned the equation I is equals to I1 plus I2 plus I3, right? So what we have to do, we have to take out the value of I from this relation. V is equals to IR, and we will get I is equals to V by R. So put the value V by R in the previous equation 1, we will get V by R equivalent, because this I is the give us the total value of resistance. Then in I1, we will put V by R1, because we know the value of V is same, but R is changed. Then we have to put V by R2 plus V by R3, right? So as we put the value, we know that this V is same. So what we have to do, we have to take this V as common, and we can write the equation 1 by R1 plus 1 by R2 plus 1 by R3. So as we know that if we see on right hand side and left hand side, this V is same. So this V and this V will be cancelled out with each other, and we will left with the equation 1 by R equivalent is equals to 1 by R1 plus 1 by R2 plus 1 by R3. So this is the relation in case of parallel combination. And in parallel combination, when we combine all the resistance, the value of parallel is small, right? So when in our daily life we use a small value of resistance, we connect the resistor in parallel combination. Similarly, if we have the n number of resistors, so we can take as equation will be 1 by equivalent plus 1 by R1 plus 1 by R2 plus 1 by R3 plus 1 by R4 up to 1 by R, and this n represent the number of resistors that we are connected in this combination. If n is 7, we have to connect the 7 resistors in parallel. If the number is 10, it means we have to connect the 8 resistance or 10 resistance, depending upon how many resistance we are connected. So this is the parallel combination. Now we will see the related problem with this. So in this example, 3 resistance R1, R2, R3 are given to us. They are connected in parallel combination. Find the equivalent resistance. We have to find out the total value of resistance and currents passed through each resistor. It's mean current passed through each resistors mean we have to find out the value across each resistor, right? In parallel combination, the formula is IR1 plus IR2 plus IR3. Just what we have to do, we have to put all the values in this equation. And when we put all the values in this equation, we will get the equation like this. See, this is a equation like this. and we will get 6 plus 3 plus 2 by 30, which is equals to 1 by RE is equals to 11 by 30 ohms. Just take the reciprocal of this equation. You can write R equivalent is equals to 30 by 11. Solve it with the help of a calculator and you will get 2.73 ohm. See, this is the very small value of combination of parallel resistor, right? Okay, as we know that the voltage across potential difference across each resistor is same, so we can say that V1 is equals to V2 is equals to V3 is equals to total potential difference, that is equals to 12 volt. Right? So again, we will use the Ohm's law, which is equals to V is equals to 1 by R equivalent, that is I is equals to V by R equivalent. Put the value and we will get the 4.4 ohms. Similarly, for resistance R1, again, we will use the formula I1 is equals to V by R1. The value for voltage is same, that is 12, but R1 is different. So dividing them, we will get 2.4 ampere. For I2 is equals to V by R2. I2 is equals to 12 by 10. Then we will get 1.2 ampere, right? I3 is V by R3, which is equals to I3 12 by 15 give us 0.8 ampere. So in this way, we can find out the current of three resistors across each of them separately. When we add them, we can also get the total amount of current, that is 4.4 ampere. Okay, so this is an example based on combination of resistor. Now the next topic is electrical energy and Joules law. Okay. To understand this, first of all, see the circuit. This is the battery that is providing the potential difference, or we can say the voltage, and it is connected with this bulb. So what is the potential difference? We know the potential difference is given by V is equals to W by Q. So basically, when we are moving the unit charge from one potential to another potential, we are doing the work done. So this work done is in the form of energy. So we can write W is equals to E, which is equal divided by Q. So so equation is V is equals to E divided by Q. If we want to find out the value of E, we can take this Q on the other side and we will get the equation E is equals to QV, right? So this is the relation for energy in case of when we are moving the point charge from one potential to another potential, right? So as we know that current is basically the number of charges flow per unit time. So the relation is I is equals to Q by T. If we want to find out the value of Q, what we have to do, we have to take this T on the other side and we get the equation Q is equals to I multiplied by T. Previously, we learned the equation in previous slide, E is equals to QV. So putting the value of this Q in this equation, we will get Q is E is equals to Q is IT, and we have to write V as it is. So we get the equation E is equals to I multiplied by T multiplied by V. Now we all know what is the Ohm's law. Ohm's law is V is equals to IR. So we have to put the value of this potential in this equation. What will we get? E is equals to as V is equals to IR, and we have to put this value of V in this equation instead of this V. So when we put the value IR over here, what will happen? This I and this I will be multiplied with each other and we will get I square. Then R will be written as it is and this T will be written as it is. And we get the equation for electrical energy. We have said that when the current is flowing in a circuit, basically there is an electrical energy. So the electrical energy relation is given by E is equals to I square R by T. Right. Secondly, if we want to find out this relation in terms of voltage, what will we do? We will use again the same Ohm's law like this. V is equals to IR and I is equals to V by R. So put the value of I in this equation, we will get E is equals to V square by R square. Okay, it will be V square by R square. Then this is RT, right? R and T. This R will cancel out with this R and we will left with this equation E is equals to V square by R multiplied by T. So these are the electrical energy equations in terms of current and in terms of voltage. If we have to find out the value of this electrical energy in terms of current, we will use this equation. And if we want to use the electrical energy equation, electrical energy in terms of voltage, we will use this equation. Okay, so the next slide is now we are going to understand that what is Joules law. Okay, Joules law of the heating provide mathematical description of resistance in a circuit converts electrical energy into heat energy. Okay, when we have learned in the class, when we draw the circuit of potential difference and we connect the bulb in the circuit, and we are seeing that the electrical energy is providing the bulb a light energy, and after that it providing the heat energy. So we can say that the electrical energy is converted into heat energy. That is basically given by the Joules law. The amount of heat generated in a resistor is proportional to the product of current and resistor and duration of time for which the current passes through the resistor. So this is basically known as the Joules law. Okay, previously we have learned the equation E is proportional to I square R by T. So in Joules